Now we want to write an equation, and this time they say in terms of sine, but the graph is given to us. So we have to look at the graph and undo the DABC in order to figure out what's happening and what we can put into our equation. So the D and the A, they kind of go together. We're looking at this graph. It's got a maximum at 6, a minimum at -4. Could you draw the center line on here? So I'm drawing the center line here. I'm saying I think it's at y = 1. How can we check if we're right? Because sometimes you're going to draw the center line and you're going to be off a little bit. You're going to think you know where the center is, but you might not be there exactly. Well, that's where the D and the A sort of go together. In that, if that is my center line, the distance from my center line to my maximum is my amplitude. How far is it from 1 to 6? 5. How far is it from 1 to -4? 5. If those numbers are the same, then you know your center line is correct, and you also just realize you've just found out what your what your amplitude is. We know our amplitude is at 5 and our center line is at 1. Some other things that people sometimes use to figure out center line and amplitude. From 6 to 4, does it make sense that this whole distance is 10? And if you go from a maximum to a minimum, that's double your amplitude. So whatever that distance is, you could cut that in half, which is 5, and then you know what your amplitude is. And if you know what your amplitude is, you could just go down 5 from 6 and you'd get to 1 and you'd get your center line as well. So we don't necessarily need to find D first and then amplitude, or amplitude first then D. You can decide whatever makes sense for you and sort of find those at the same time. Now, our B value is based on our period. When we had an equation, we said period is 2 pi over our B value. If you rearrange that equation, you get that your B value is 2 pi over your period. So we need to look at our graph and figure out what our period is. Well, one way of doing that is to take a point, say a minimum, and a full period is when it gets to that minimum again, from one minimum to the other. Now, if I just count boxes, 1, 2, 3, 4, 5, 6, 7, it's 8 boxes, or 8 lines from one minimum to the next. But what is that in this scale? If I look at the scale that I've been given, it looks like 2 boxes is pi over 6. So one of these lines is going to be pi over 12. And if from one minimum to the other minimum goes 8 of those, that tells me that my period in this case is 8 pi over 12s, or 8 pi over 12, which reduces to 2 pi over 3. If you use the formula that says your B value is 2 pi over your period, you could now substitute your period in, and you get this nasty fraction with a fraction, 2 pi over 2 pi over 3. But then we remind ourselves, okay, if I'm dealing with fractions and I'm dividing by a fraction, what are my fraction rules? Fraction divided by fraction means multiply by the reciprocal. So on the top I have 2 pi over 1. If I multiply by the reciprocal, I have 3 over 2 pi. Oh, something nice happens. And so our B value is 3. Another way that you could have found your B value. So we had this formula that your B value is 2 pi over your period. When we did it the other way, we had this formula that your period was 2 pi over your B value. Right? Can you see that we had our period to be 2 pi over 3? I wonder what B is if it's written that way. So if you can write your period as 2 pi over something, then whatever that something is will be your b value. So there's another way that you could have found your b value. You can either use the formula that's already got b by itself, a little bit of dividing by fractions, no problem. Simplify, we get 3. Or if you could rearrange your period to begin with to be 2 pi over something, which in our case it worked out nicely that that happened, then whatever that is over will be your b value. Now finally, we need to figure out what our c value. What is the phase shift? In this example, we want to write an equation in terms of sine. So we're thinking about sine graphs. And so in order to figure out the phase shift, we need to figure out what the starting point is. Where does a sine graph start? A sine graph starts on the center line at a maximum or a minimum. Okay, because if we say 0, 0, there's no point at 0, 0 here, so we'd be like, I don't know how to use that. But if we say that a sine graph starts on a center line going up, and we look at our graph and say, sure enough, there's one right there. There's a center line going up 3 boxes to the right. Well, how could I write that as an equation? Y equals, my amplitude is 5. Sine, my b value is 3. And if I've moved 3 boxes to the right, those are 3 pi over 12s. And you could reduce that to pi over 4 if you wanted, plus 1. Now I'm going to put a little 1 beside this equation, because this is the first equation we're going to write. You could write another equation, because if I looked at my graph, I could have chosen that point as starting on the center line going up. But then if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, that equation would be exactly the same with a shift of 11 pi over 12 to the right. But that's not the only equation with sine. I can make another one. I could say, well, I know that negative sine graphs start on the center line going down. So if I find a point on the center line going down, then I could have everything the same, except now I'd have a negative. And now my shift would be pi over 12 to the left. And so on and so on. And we just created 3 possible answers with sine. You could also create possible answers with cosine for this graph, because cosine starts at a maximum. Yes? I won't ask you to list 3 different ones, but I would, typically you'll get one like this that says, write 1 equation with sine, 1 equation with cos. So for the cos graph, the d, the a, the b value, they stay the same. The only thing that changes is where you start. So your c value, the shift, is your starting point. If I wanted to do a cos graph, I'd start at a maximum. If I wanted to do a negative cos graph, I'd start at a minimum. And so you have lots of different options. And no matter which option you choose, as long as it's correct, it gets marked right. There's no one right answer for these ones when writing an equation. So your questions for practice on this one are 4, 5, 6, and 7.